Alright, so I chose to do my project on the atomic bomb and its effects on science because World War II history has always been really interesting to me, and the atomic bomb is really what shaped a lot of the 20th century in just context of what it helped develop and all that. Alright. Because, without the atomic bombs, there never would have been the nuclear tension of the Cold War, hydrogen bombs never would have been developed, stuff like that, and we would probably still be fighting conventional wars. But that doesn't have anything to do with science, so. Right, the Manhattan Project was what was responsible for creating the atomic bomb, which started in 1942 with the intent of building a weapon that could end the war swiftly. Because at the time, a Japanese invasion of the Japanese home islands would have been deemed almost suicidal by the American commanders because the invasion would be larger than D-Day, with just naval capacity, and they knew that the Japanese would fight desperately for their homeland. So the project successfully developed two bombs, which was Little Boy, which had a uranium reaction, and Fat Man with a plutonium reaction. The both reactions came from the release of fission of the nuclei from the heavy elements, and that chain reaction caused an explosion. So, like I said, the first two atomic bombs were Fat Boy and Little Man, and Little Boy and Fat Man. That's what. Okay. So Little Boy used a gun method of explosion, which is something like right here, where a conventional explosive hits the heavy element, and then that causes the chain reaction. And then Fat Man used a implosion method where the explosives went around the heavy element. Little Boy used the Little Boy used uranium, and Fat Man used plutonium. So Little Boy, it had potent U-235 uranium, but that was hard to separate from the regular, more common U-238 uranium, which didn't really like fission all that well and cause the proper chain reaction needed for an explosion. All right, so Little Boy, like I said, used the gun method of construction and needed the U-235 uranium to generate the fission needed for the nuclear reaction. So the challenge they faced was separating the U-235 uranium from the U-238 uranium, and the U-238 uranium did not generate enough fission to cause an explosion. Now, only 0.7% of uranium is U-235, so they had to come up with a method to separate and purify it. And they tried four different methods, which were gaseous diffusion, centrifuge, electromagnetic separation, and liquid thermal diffusion. Now, they obtained enough U-235 to do this, but this was too complicated enough that they weren't really wanting to do that again for future bombs. And this one had a decent issue because if the two like masses of uranium did not combine quickly enough, the spontaneous fission would occur, which would cause the bomb to fizzle out and not explode. It was dropped on Hiroshima and caused massive damage to the city on August 6, 1945, and it contained 64 grams of uranium, but less than a kilogram actually underwent fission. So most of the material wasn't really used, meaning that the explosion could have been bigger. Fat Man was the second successful atomic bomb, and it was different in the method of construction and in the element that was used. It had the implosion method instead of the gun method, where the two elements didn't have to collide because the explosion from the conventional explosives would cause the plutonium to consolidate and start a chain reaction instead of having something that could go wrong, like with the gun method. As the bomb was powered by plutonium 240. They tried to do it with 239, but they only collected 240 from the nuclear reactors of the time because the nuclear reactors weren't all that advanced yet, so they kind of had to work with what they had. This was the reason that they used the implosion method instead of the gun method was because plutonium 240 would undergo fission much quicker than the uranium 235, so they couldn't use the gun method because that means it would explode before the two masses impacted. They dropped it on Nagasaki on August 9th, 1945, which ended World War II, and this is the last nuclear weapon that was ever used in warfare because we realized that these are kind of dangerous. So, the invention and use of nuclear weapons increased enthusiasm for nuclear power, so more nuclear generators were invented, and we still use that for a decent amount of power today. So the unused heavy materials in both bombs led to the creation of better methods in the hydrogen bombs, which were dangerous and, like I said, caused a lot of Cold War tension. And the effects of the bombs when dropping on the two Japanese cities caused a lot of strange effects in people. You know, the people who survived the blasts, they had a lot of strange health effects as a result. So that led to innovation in the field of radiation biology, right? So, like studying what it did to people and the surroundings and all that. So, with that sort of study, we've invented things like chemotherapy, and we've learned more about radiation and what it does to people. So, without the atomic bomb, science probably wouldn't have developed as much, and we'd still lack proper understanding of the effects of radiation. So, thank you for watching.